What's up guys, welcome back to the channel, and welcome back to another video. Now in the last video you saw that we installed the remnant 44mm wastegate on the 3.8 turbo, going to dual remnant 44mm wastegates. Now today we're going to be doing some additional testing of this setup. So in the last video I installed it with the 5.8 pound spring, and that set us up for dual 5.8s, which in theory should make around 5.8, 6 pounds of boost. We did some testing already of this spring setup in the car, also looking out for whether we still have the issue with the boost tapering off as we're going through the RPMs. And the boost is a lot better now. It's not nearly as big of a drop off as it was previously. When I was on the on-3 gate, I could see as much as 2.7, 3 pounds of boost drop off throughout the RPM band from peak to red line boost, which is significant power that we're losing. So with this current setup, we have tested it a little bit on the 5.8 pound spring, and we still have a little bit of boost drop off. It lowers as I go up in duty cycle, which is kind of as expected because of what I think is actually going on and causing this issue. But for today's video, we're gonna do some additional testing and actually switch out the 5.8 pound springs to the 7.25 pound spring setup. As I said, we've already done a little bit of testing with the 5.8 pound spring setup. On 0% duty cycle for the boost controller, we peaked at a 7.93 pounds of boost and tapered off to probably around 6.5. As I turned the duty cycle up and we made a little bit more boost, we got all the way up to 46% duty cycle, and we made 9.98 peak boost, and it only dropped off to 9.07. So that 0.9 pounds of boost drop off is much better than it was with the old on-3 performance wastegate. But I know that we've had setups on this car that have had zero drop off throughout the RPM band. So we definitely want to figure out what's going on and what we can do to fix this. So I think it's a combination of maybe a couple different things. For one, the boost controller has the function for setting the crack pressure, which is basically the pressure at which the boost controller will start to control boost. So, if you have a 7 pound spring, it may start to crack open a little bit before 7 pounds of boost. So you can set your crack pressure on the boost controller to, 4 or 5 pounds of boost. And then before the wastegate starts to crack open, which is going to slow down the turbo, slow down your spool, the boost controller will start to add boost pressure to the top of the gate in order to keep it shut and increase your spool. Now, if you go too low with that, what can happen is the turbo doesn't have enough time to slow down, and you end up overshooting what you're trying to make, and then it comes back down and resolves to where it's targeting to be at based on the spring pressure. So I have been testing this car, and when I was switching between different wastegate springs, I wasn't changing the crack pressure every single time based on the spring that was in the car. So the most recent testing, I had the crack pressure set at 1.5 pounds of boost, which basically is nothing. As soon as I start making boost, it's going ahead and trying to control boost, adding pressure based on the duty cycle to the top of the wastegate with the 3-port Mac valve solenoid. So I was thinking maybe that 1.5, even with the 5.8 pound spring, if it was 3.5, 4 pounds of crack pressure setting on the boost controller, maybe that would be better. And what's going on is I'm actually overshooting the boost that I'm trying to make before coming down to what it sits at. I don't really think that that's what's going on, just because we see the boost taper off when we're running 0% duty cycle. So with 0%, it should effectively be set up like there's no boost controller and it's just running on a wastegate. The solenoid's off, so it's not doing anything. But we still see that boost drop off on 0% duty cycle. So I'm not convinced that the crack pressure setting on the boost controller is the culprit for it, but I have switched from the 1.5 PSI to a 3 PSI, and we will see if that makes a difference in the setup. Not only that, but at some point, I can't exactly remember when, but at some point I changed the boost reference from the vacuum block, which is connected to the intake manifold, to the compressor housing of the 70 Omega, since this has a port on it for boost reference. And the reason I did that is I was trying to get away from having vacuum applied to the wastegates, so getting a boost only source for operating the wastegates. What I think could also be going on is when you're referencing the boost from the turbo, you're going to have pressure drops throughout the system. So what the engine is seeing is not exactly going to be what the turbo is seeing at that same point in time. So you're going to have pressure drops throughout the intercooler piping across the intercooler. So that could be causing some things as well. The airflow at the turbo is going to be much more turbulent, so it's going to be subject to more pressure fluctuations and perturbations, versus if you were taking at the intake manifold or close to it, it'd be much more smooth flow of pressure reference. So it could be that the fluctuations in pressure created by the turbo reference is causing the boost to come up and then lower down. Not exactly sure, but I could go back and reconnect the boost reference to the vacuum block to test whether that makes a difference. But what I think is actually going on is likely some back pressure causing the wastegate from the original location to open up wider throughout the RPM band based on the spring rate in that wastegate. So it seems like from the testing we've already done with the car, either you get to a certain duty cycle with the MAC valve where you're applying enough pressure on top of the wastegate to get rid of the taper off and boost, or when you go to a stiffer spring, then it eliminates that taper off. So now if it is a back pressure issue that is causing the drop off, switching to a 4-port boost solenoid would help to combat that, because then I not only could add boost pressure to the top of the gate, but I could cut off the reference to the bottom of the gate, which would aid in not allowing the wastegate to reach that position where back pressure is much more easily able to push it open more. So before I decide to switch up to a 4-port, and really just thinking about it more and more, what the hell are we doing trying to run 7.9, 8 pounds of boost on wastegate, man? That's not enough for this car. We know we're prepping the car for port injection to come out, so we're gonna be turning the boost up. The 5.8 pound springs that we have in it right now are not gonna get us to where we wanna be once we get port injection. So let's quit playing games and go ahead and pull these wastegates out, take the 5.8 pound springs out, switch to a 7 1/4. I suspect that will put us around 9.3 to 9.5 pounds of boost on wastegate. And we'll see if that taper is still present with boost as we travel through the RPM. So let's go ahead and get started with that. All right, guys, it is much later, as you could tell. Ended up spending the day relaxing a bit in the pool. It was so hot. I mean, even by the time I was recording the last clips, it was 105 or more degrees in the shop. So we did get the 7 1/4 pound springs in the 2 wastegates. I'm gonna have to end up pulling one of them off to Loctite all these set screws for the diaphragm to the wastegate valve. But before I do that, I am gonna take the car out and just do some preliminary test and see how much boost it makes with the 7 1/4 pound spring setup. So let's go ahead and get the car started, warmed up, and we'll take it out and see how it does. All right, guys, like I said, we've got the 7.25 pound spring set up in the car now. We're gonna do a 3rd gear pull and test what the wastegate pressure is. Right now the boost controller is turned off, so we should be at 0% duty cycle. No real impact to what boost pressures we're making. Let's see what it makes. made less than what it made on the 5.8. So yeah, these are, you know, the issues that I'm dealing with, where shit just ain't adding up. So let me test a few more things and then we'll get back, and I've got to seal those set screws, so we'll go ahead and pull the wastegate off and do that, but let me see what the hell's going on. While I'm figuring this out, let's see if I can get any clips of the car shooting flames. Usually you just give it some throttle, let it kind of rev down on its own, and then once you get back on throttle, see a little flame there? See if we can get a better one. Saw a little flame. Guys, doing some more testing since last night's testing didn't go great. Swapped out the 7 1/4 to the 8.7 pound spring setup. Still not exactly getting the results that I was expecting, but we're at 33% duty cycle. Let's see what we get. Take a moment to appreciate how freaking amazing this car sounds.
One day later.
Well guys, doing some additional testing and we finally figured it out. So we'll talk more about what was the reason for the boost taper once I get back to the house, but I figure while I'm out, I'll go ahead and show you. This is with the boost controller off. Wait for traffic to clear up in Mexico City. Watch that boost. Stable. No longer dropping off. Before it would hit like 6.4, drop all the way down to 4 pounds of boost. Now it's holding stable, so we have figured it out. Well guys, as you would have seen from that previous clip, we finally figured out what is going on with this car and the reason that it was seeing that big taper off in boost as we go through the RPMs. And I started suspecting what the problem might be when I started looking back at some clips that I had from throughout the process of doing some recent modifications to this car. We had tested the 5.8 pound springs. We had the boost drop off. We went to 7 1/4, thinking the stiffer spring might, you know, combat a back pressure issue if that's what was going on. It didn't really help. We still had the boost taper from peak to redline boost. Then we went to an 8.7 pound spring, and once again, we still had the same boost tapers. So to rule out there being an issue with the wastegates, what I actually did was I swapped the positions of the two wastegates. So I put the new one that I got in the other position and then vice versa. Tested it out, and it basically made, in theory, the same boost at every duty cycle when they were swapped. You know, there were minor differences, which is expected just from taking the car out on a different day with humidity and the temperature and everything, but they were very comparable. So I started thinking more about it, and I'm thinking more along the lines of, well, we talked about the pressure drops that happen as we go throughout the intercooler piping and across the intercooler. So maybe that has something to do with it. Because I know that I used to run the wastegate reference line from the intake manifold, and at some point I switched to the compressor housing of the turbo, since there's support for it now on the 70 Omega series turbo from Retuned Performance. So I switched the wastegate reference back to the vacuum block, which is connected to the intake manifold. And as you saw from those last clips, the car hold boost real stable. Obviously there are going to be some fluctuations based on the amount of significant figures that my boost controller reads out to, but the minor fluctuations are totally normal. Definitely a huge shift in boost taper that we saw from referencing the compressor housing versus the intake manifold. And it makes sense, because if the wastegates are being controlled by the turbo, then as long as the turbo remains stable as far as the pressure that is outputting, the wastegates are not going to change their position. But as we go through the RPMs and the airflow demand becomes even greater on the engine as it's speeding up in revolutions and intaking more air, exhausting more air, the pressure drop is only going to be exacerbated by that shift in demand. So if the compressor housing is the reference for the wastegates, they're just going to remain stable, and that pressure drop and pressure flow reduction is going to continue to grow and grow as we go through the RPM band. Now having the wastegates reference the actual boost pressure that the engine is seeing, it's going to remain stable as far as the intake manifold pressure. As that were to drop, the wastegates are going to close, which is going to speed up the turbo and keep the supply to the engine stable. So that's great that we were able to figure that out and get the car where it's not losing 2 to 3 pounds of boost or more throughout the RPM band, which is significant power that we were losing out on. So now the testing is going to once again continue, and we've got a little bit of testing from that wastegate pool, and I think I did 10 and 15% duty cycle. But as we always do, we'll build out a band of duty cycle for the current 8.7 spring setup in the wastegates, verify that will get us to that 11 to 12 pounds of boost that we would need for a max effort direct injection build, and still have room to grow for port injection once we get that installed here shortly. I hope you guys enjoyed this video. That's pretty much going to do it. Obviously more to come on the build as we continue to test, and then port injection installation and testing of that. So I hope you take care and have a great day.